All right, I'm on page 359 of the book. All right, so we are going to start something new today, and what we're going to start new is a section on object-oriented programming. It's chapters 12, 13, 14, 15, and 16. Believe it or not, what I'm going to do today is I'm going to go over the first half of chapter 12. All right? And I'm not going to lie to you, I forgot all about doing that auction thing. Don't worry about turning it in. We will get it done. And we will go over it as a class. I just don't know when I'll have time to do it. It might not be till the break. All right? So we will go over the first half of chapter 12 today. Then I'm going to give you the written test, just hand it out to you for chapter 12. It won't be due till we get back from the break. We'll finish chapter 12 up tomorrow. And then on Wednesday, we're going to do the same thing Wednesday and Thursday with chapter 13. We're not going to go through a lot of code right now. We're going to go through more code after the break. Why? Because if we go through it now, you'll have just enough time to forget it during the break. All right? And why? Because this is my opinion. You do whatever you want to do. I wouldn't pick up a book during the break if I could help it. Now, I'm not you, and I've already got a ton of stuff planned for the break. All right. Plus, my mom turns 90 on Wednesday, so I've got to go and see her this weekend, and and a bunch of other stuff. But that's neither here nor there. All right. So it says in here we have already been using object-oriented programming. You probably just don't realize it. In other words, every time we've created a button is a button object that's a member of the button class. All buttons have things in common. They all have a size, they all have a text color, etc. And all the buttons, typically, if you create 5 buttons in a program, they'll all be different. They could all be the same size, they could all be a different size, etc. But you hopefully at least get the idea. All right. Now, what we're going to be talking about now, though, and for most of the rest of the semester, is creating your own classes. All right. And what I'm starting to do right now, probably I'm going to create 2 different, and they're going to be big examples that we're going to do as a class. Why? Because I want it to make sense to you. I was looking at the first set of labs that he's got, and I think that after we go through chapters 12 and 13, I think you're going to be more confused than anything else. So what we'll do is when we get back from the break that week that we get back, what we're going to do is we're going to probably spend a lot of time, and I mean a lot of time, going through 2 examples as a class that we can keep building on. Then when you get your lab, all right, the lab will be on 12 and 13. It'll be a combined lab, okay? You'll have at least 2 class periods to work on the lab, if not more. And at least one of the problems on the lab, and maybe 2, but at least one, we'll do as a class. All right, so you can see the kind of thing that we're looking for, etc. All right, so in chapter 12, as it says, it shows you the basics of creating classes. Now, one thing about this, you're all smart enough to realize this yourselves. This is when the author says these are the basics of creating classes. Yeah, these are the basics of creating classes as far as Muroc is concerned. Not every book, not every author, not every article that you see will do things exactly the same way. And that should just make sense. Then in chapter 13, we will add some advanced features. Indexers, delegates, events, and overloaded operators. What I have decided to do, be this right or wrong, good or bad, whatever, for the last 5 chapters that we're going to go over, I've got your written test here. What I have been doing has been boiling them down. I've been taking a lot of the questions out. I didn't do that this time. There's 21 short answer questions, and there's 26 multiple choice. I want you to do all of them. And I'm going to make it worth 50 points. You get 3 free points, but 21 and 26 is 47. So that's what we'll do. And we're going to do that for the rest of the semester. At least you're going to have a good fundamental understanding of what it is we're going over. Now, the funny thing about this, not haha, but you can read articles out there on the web. Object-oriented programming is dead. Object-oriented programming stinks. You should always use object-oriented programming. You should never use object-oriented programming. It depends on who you read. There are languages that are totally object-oriented. And you may or may not realize that what we've been doing thus far, we have been doing some object-oriented stuff. All right? When you get into the fourth semester and you're working on Java, Java is a totally object-oriented language. All right? Now, we never really went over any object-oriented programming in the JavaScript class. You two didn't do any of it. Probably when, if you take the class, or when you take the class, hopefully in fall, that we'll have at least a period or two that we'll spend on it. But that's not enough time to make you an expert. It's enough time to introduce you to it, and that's it. All right. Then we'll get into Chapter 14. Chapter 14 is inheritance. In many ways, not every way, but in many ways, inheritance in programming is like inheritance in genetics. In other words, and I say this not a joke and not to be funny or mean or anything else, but typically, if two people get married, and they both have really big noses, let's just say, and they have a kid, there's probably a pretty good chance the kid will have a big nose. That's genetic inheritance. I know it doesn't always work like that, but normally that's the way that it works. So what can the kid do? Live with it? Get a nose job? Okay, but that's really, when you think about it, that's probably about it. It's not like they can take the nose off and put another one on. But you can do stuff like that with code inheritance. If you don't like something you've inherited, you can totally rewrite it. All right, and we'll get into that in Chapter 14. Then in Chapter 15, we'll get into what are called interfaces. Now, you may or may not know this because we're going to talk about a lot of fundamental terms in here. But when you inherit in most programming languages, when you use inheritance in most programming languages, you can only inherit from one parent. Now, that's not like genetic inheritance when you inherit from two parents. But in code, most languages, you inherit from just one parent. There's reasons for that. We'll get into it at that time. All right? But it's important that you realize, now C++, not the language we use in here, is one of the few languages where you can inherit from multiple parents, but not this one. So why am I even telling you that? All right, because although you can only inherit from one class, you can do what's called implement as many interfaces, and an interface is like a stripped down class, as you want. All right, and again, I'm throwing some stuff at you. We haven't even started the chapter yet. So I don't expect you to remember this, but at least you kind of talked about that before, kind of an idea. Finally, when we get to Chapter 16, I think that's a pretty short chapter. That just talks about how to document your classes and how to make them so they read a little bit better. Some tricks and stuff that they would recommend. So this is Chapter 12, how to create and use classes. I'm going to go over this in a second, but if you look here, today we're going to go over an introduction to classes, the basic skills for creating a class, and we'll get into the product maintenance application so you can at least see it. All right. Tomorrow we'll go through more skills for creating a class, how to browse diagram and display and edit classes, and how to work with structures. All right. So as it says, the chapter presents the basics of creating and using classes. All right. We'll learn how to create a class. We'll learn how to include properties, methods, fields, and constructors. You might know what those words mean in context of a class. You might not. As well as classes that contain static members. We've used the word static before in our code. All right. In addition, we're going to go over this complete application that uses 3 user-defined classes. So we're going to go over all of it. And my hope is when we get done, you'll say, you know what? Yeah, it is something new, but I sort of understand what you're talking about. If you can get to that point, that's good. All right. You do not, I don't think you come out of this class where you are an established object-oriented programmer. I still, when I go through these chapters, I still learn stuff all the time. All right. So as it says, when you complete this chapter, you'll start to see how creating your own classes can simplify the development of an application. Again, that said, you may not agree with that as we go through it. All right. So what they talk about. Now, one thing, and Angie, I realize, you know, that you're a little bit behind the 8 ball here because you didn't have the last class. But what I want everybody in here to realize is we went through something last semester where we talked about HTML, the hypertext markup language. Then we talked about CSS, cascading style sheets. Then we talked about JavaScript. All right, why am I telling you that? Because we talked about 3 things that work together. All right, the HTML allowed us to put in the website's content. The CSS allowed us to pretty it up, so to speak. All right, and it worked on what we show the end, user, the person looking at the website. And JavaScript allowed us to put in some logic and some interactivity. So who cares? All right. Well, when you look in here, in this chapter, they're going to talk about a multi-layered architecture. And they talk about a presentation layer, a middle layer, and a database layer. It's not the same thing, but the presentation layer, it's kind of the way we've been using CSS. It's the way you show things to the user. All right. The middle layer, that's going to have our logic in there. All right. That's kind of a combination of your HTML and your JavaScript. And so is this. When we get to chapters 17 and 18, that's all we'll cover in the book, you'll get an exposure to databases. Virtually, though, I believe most of the stuff that we create in here, most of the stuff that we create will be console. Classes are console, but you can hook classes up to GUI programs. All right. Why would you want to do that? Because it gives the GUI program some language and some smarts that you can strip away from a GUI program. Why would you want to do that? So you can take that logic, those smarts, and put it also in other programs. All right. So again, as always, there's a reason for doing this. All right. So they call this a 3-layered application. And I'm not going to read this to you. I pretty much have gone over it as it is anyway. Now, with some applications, the way they're built, what they do is literally they don't have this middle layer. They'll go and they'll combine part of that middle layer into here, part of that middle layer into here. So you might say, well, who cares? What's the big difference? If you can write an application more like this, there you have what's called a separation of concerns. What does that mean? That means that this is only responsible, typically, like if you're writing a website, for showing the basically for showing the actual website on the screen. All right. This has got all the logic in it, and most every application that you create directly or indirectly touches a database. So all of your database logic can be put in here. That's what you shoot for. And again, I'm not saying that it always happens. All right. So it says here, many applications use this 3-layered architecture to separate the user interface, the business rules, and the database processing. What's a business rule? It's a rule that makes the business work. All right. I've been having some problems with my eyes. So I'm looking for a good eye doctor, and I thought I'd found one, but I actually want to go to an ophthalmologist, not to an optometrist. All right. So why am I even telling you this? Because I'm going and I'm looking at a bunch of places online. What do they have on their website? Their hours. That's a business rule. They're open during these hours. The insurance they will or will not accept. All right. Or what they'll do if you don't have insurance. Those are business rules. All right. So anything like that can essentially be a business rule. All right. And again, what you'll find is most of the time, you're also going to have this database layer. And what does that do? That basically has got the database that's got the stuff in there that enforces your business rules. All right. And they mention oftentimes classes that make up the database layer and this middle layer are implemented in class libraries. So you can use them in your application and in other applications. And, you know, before you say I get that or I don't get it, you get it because haven't you been using, for example, the button class in multiple applications that you've created? All right. All right. So it says here the members you can define within a class. These are just a bunch of definitions, but they'll be on the test, and there'll be things that you have to start understanding. All right, so it says properties that you design yourself can have properties, can have methods, can have constructors, can have events. Let's just talk about what each one of those are. All right, so let's suppose that we talked a little bit last week, we went through those examples with employees. All right, and we said, for example, employees had first name, last name, ID number. All right. Each one of those, first name, last name, ID number, would be a property. When we set the employee's first name, or when we get the employee's first name, or set or get the last name, or set or get the ID number, those are methods. So properties are individual characteristics. Methods are behaviors. So if I created a class and I call that class human being, all right, I would put something in there like every human being would have an eye color, all right. That's always the old joke. They all have a hair color. People say, what's your hair color if you're bald? You know, that kind of an idea. But you understand what I'm saying. Everybody has an eye color, for instance, all right. Everybody has a gender. Even that is always subject to debate. I get all that stuff. All right, a constructor, you're going to see that. We talked a little bit about this. But whenever you create, what we're going to end up creating in here is a class. We're going to start to create classes in here. So imagine, if you would, that across the street from Rankin Technical College, as you come in on Power, and I get mixed up where exactly that is on here, but there is a field over there. All right, so imagine that some developer came in, bought that field, and decided they were going to put a neighborhood up in there. And in that there was space in there, let's just say it's 100 acres. And, with all the roads and all the other stuff, they figured out they could put in about 60 houses. Okay? And on that 60 houses, there were going to be 5 house plans. So there would be plan 1, plan 2, plan 3, plan 4, plan 5. Then in the next row, 1, 2, 3, 4, 5. It wouldn't be varying a lot. Each one of those house plans that they create would be a house plan class. Each time they created a house based on those plans, that would be an object. You are all human being objects. Okay, you all have eye color, hair color, gender, etc. But the eye color, hair color, gender is not the same amongst any of you 3. All right, that kind of an idea. All right, and events, you know what they are. We're used to responding to button click events, but there's other kinds of events you might want to respond to. Okay, so they've got some stuff in here, and they're saying, let's say that we created a class, and that class was going to represent a product. We don't even know what it is, but you're selling something. So we're saying here that each product would have a code, each product would have a description, and each product would have a price. And when you think about it, that all makes sense. I mean, imagine that you go into Lowe's and you're going in there to buy a certain kind of nail. All right? There's probably a pretty good chance that when you go to where those nails are, you're going to find a code in there. All right? And under that code, there will be a description, the size of the nail, etc. And each one of those nails will have their own price. All right? Then we've got in here get display text. That's a method. Now notice, well, all that is, it's just a method that's going to give you a string that shows the code, the description, and the price. That's it. All right. So if somebody comes in there and says they I need a penny nail that's 2 inches long, etc. Somebody can maybe go into, if they're at Lowe's or whatever, can type into their computer and it can come back with display text that says, hey, maybe there's even more than this. Maybe it tells you what aisle it's in, etc. But it's got the code, it's got the description, and it's got the price. All right. Also in here, when we create a new project, or a new product, I should say, we're going to have 2 different constructors. We can have one constructor where we pass in nothing. What does that mean? You'll see it in a minute. We can have another constructor where we pass in the code and the description and the price. What that means is when you come in and you create a brand new product, you must either provide nothing or you must provide 3 things. You can't provide 1, you can't provide 2. It's got to be all or nothing. That's what they're saying. So they formally give you some definitions here. I'm not going to read any of them, but just take a look at them if you would. You don't have to memorize them. All right? But this is a page that some of those questions that are going to be on your written test, they're going to give you some of the answers here. So the author defines an object as a self-contained unit. Each one of you is a self-contained unit when you think about it. All right? And it has properties, which I've already explained, methods, which I've already explained, okay, and it has other things. An object, so you are a member of the human being class. I like to think I am too. All right? The class, as it says, contains the code that defines all of us. We are all objects, meaning we're all instances of the human being class. When you create a new instance of a class, it's called instantiating or class instantiation. They mentioned that there. You've got encapsulation. I may have given this example to you guys last semester. I don't know. But if I come up here and I go into here, for example, I go to calculator and I type in 367 and I hit, I think that's the square root button. No, it's not. Well, one of those is the square root, right? I don't even know which one it is in here anymore. So the point is, all right, if I found it and was able to click that and I put in 367, it would give me a number, whatever it was, 16, 19, whatever it is, something like that. But I don't know about you, but when I do put in a number, I don't care what the number is, and I click any of these things that are here. Even if I do something like 89 divided by 6 and hit enter, I don't know internally how it gives me that 14.83333, etc. What I see is referred to as the interface. This is my calculator interface. But if somebody tomorrow would figure out a better way to do math and my interface didn't change, I wouldn't care. But what would be nice about that is if they found out a way to do math better, maybe they could do it faster. All right. Well, that didn't take any time to do that. But if I'm running an operation where I'm doing millions of calculations per second and somebody can speed that up, that's going to help me. All right. So this is my interface. What happens or what goes on behind the scenes is called the implementation. The implementation is how you do the interface. All right. But much of that information is what's called encapsulated from me. Just in the same way, I don't know about you, but this morning I got in my car, it was in the driveway, I put it in reverse. No, my wife backed in my car yesterday, so I put it in drive, and I got out of the driveway. All right, what didn't I want to do? I didn't want to put it in reverse, because then I would have went through my garage, right? All right, but what I'm saying is, when I put it into park and I hit the gas, I don't know behind the hood under the hood what happened, and I don't care. I just care if it doesn't work. But the details of what actually happened are encapsulated from me. And as it says, encapsulation is one of the fundamental concepts of object-oriented programming. It allows you to control the data and the operations. It allows you to basically say, this is what my implementation is going to be behind the scenes. This is what the interface is going to be, what I'm going to let you see. So what did I see about that? I saw that my car has, it's an automatic, but it's got a shift that's on a console, and I have to put that into drive. All right, I've got a gas pedal just like you all do. All right, I've got a brake pedal just like you all do. But at the same time, it's not a manual, so I don't have a clutch. All right. So as it says, the data of a class is typically encapsulated. All right, it's typically encapsulated, and it uses what's called data hiding. I'm going to give you a one-sentence definition of object-oriented programming. It's not 100% correct. Basically, what object-oriented programming is you using public methods to modify private data. In a nutshell, that's what it is. Public methods to modify private data. Can you have private methods? Yes. Can you have public data? Yes. But as you're going to see, most of the stuff that we do will involve public methods, private data. When you make something private, you're hiding it. You're saying the only way that you've got control or you can do anything with this is to use something I provided for you that's public. All right. It says, although a class can have many kinds of members, most of the classes that we create will have properties, will have methods, and will have constructors. All right. So what they're going to show you here, and it's not till 367, is code for a product class. All right. So I'm going to bounce back and forth, but this is what we get. And to do this, you've seen a little of this, but if I come in and so if I come in here to Visual Studio and I say I'm going to create a new project, I'm going to keep this really simple. It'll be a console app, .NET Framework, and I'm just going to call this class example. Probably not going to keep it anyway. It's not going to really have very much in it. You're not going to probably even learn very much from this. But all I want to show you here is when you do this, now what you'll see is main really will be a driver. All right? And what do I mean by that? We will now come in here, we will right mouse click on here, choose add, go down to the bottom and choose class. So if we wanted to make a product class, we'd come in here and we type in product. Boom, there's our new class. Class product. All right? And whatever we put in there, whatever it happened to be, if I wanted to create new products, I would typically do it in here. It's a driver. It'll call what needs to be called from that class file to do what it has to do. All right. And again, I'm not saying, hey, does that totally make sense to you? It might. It might not. All right. So here's an example of what we could put in there. Now, I could literally highlight all this and copy it in. All right. But I want to show you what's in here. First of all, if you look, I think you'd all agree, these three fields, they're not inside of any method or function. Okay? So these three fields that are right here, these are called instance variables. What does that mean? That means if I create 10 products, each product will have its own code, each product will have its own description, each product will have its own price. Now, it's quite possible that two products could have the same code and or two products could have the same price. But you wouldn't find two products with the same code, description, and price. That's like you can have two people who are identical twins, and they might even have identical DNA, but they're not the same person. All right. So again, these right here would be our properties. When you create a brand new product, you have to create it either like this, where you pass in nothing, or like this, when you pass in a code, a description, and a price. And when you look at here, one thing you should notice, we're not doing any validation whatsoever in there. We're saying whatever we passed in for the code is the code. Whatever we passed in for the description is the description. Whatever we passed in for the price is the price. So you might look at that and say, hey, that's fine, but what if you left that blank, or you put in hello, or you did whatever? No, it won't work. Because when you attempt to call this, you'll be attempting to pass in a decimal. And if that decimal is not a decimal, if it's blank or if it's a string, you'll get an error right there. All right. We still could do work in here. But if you look, because this is where it starts getting, in my opinion at least, a little bit confusing. All right. This says you've got a code, a description, and a price. Code, a description, and a price. Okay. These are the instance variables right there. Here is where you're actually setting them. Now that can look a little bit confusing. Notice code, description, price. I think you'd all agree every one of them is lowercase. But notice in here, capital C, capital D, capital P. Yeah, this is one way of setting properties. That's what we're going to be starting to go over. Now when you look at it, you've got in here two things, and those two things are called getters and they're called setters. We've talked somewhat about these before. Guess what? Sorry, you're going to hear them again. Getters are called accessors. In other words, they allow us to access something. So what does this mean right here? It means give me the code. That's all it means. Give me the description. Give me the price. What that means is this is taking code, description, or price, putting it on the right-hand side of an equal sign, and allowing you to assign it to a different variable, something like that. On the other hand, these sets, now you're setting something. You are changing the value of the code or of the description or of the price. All right? And you'll notice that in all three cases, it says code equal value, description equal value, price equal value. Well, I don't know about you, but the first time I went through this, I found that confusing because I'm like, where the heck did value come from? That's the value that you want to set it to. Okay, it automatically goes in as a parameter named value. All right, again, these aren't my rules. These are just the way that they are. So right now you have what? You've got three variables right there. All right. You've got two constructors, one that does absolutely nothing, one that sets everything. All right. And you've got, bless you, you've got also, bless you, you've got three different properties. And each property has its own get method, and each property has its own set method. Now, I don't want to confuse you, although this probably will, but I want to show you this. I want to grab this right here and copy it. Don't worry about this right now, but you'll see this. I think it's in the next chapter, but we'll find out. So if you come in here and you do this, yeah, I gotta clean this up. It's really ugly. All right. Public string code. Get. All right, and that get would say return code, and the set would say the other one, code equal value. Now, I'm telling you something here. I'm not asking you. I am telling you that, that right here, when we do this, we're not doing any validation. We're just saying, give me a code or set a code's value. There's a shortcut for doing this. And you'd be like, oh, that's good. Yeah, it's really good, because if I want to do it exactly like this, all I can write if I want to is this. Public string code get set. That's it. This is the same thing as this. And I don't know about you, I like the second one. It's a lot less to type. All right. So why would I use the one that's in gray right now? If I do want to do some validation or something on it, maybe I only want to, for example, for a price, maybe I only want to accept the price if the price is greater than a penny, greater than or equal to a penny. All right, because I don't have a hardware store, let's say, that sells different nails and whatever, where I just give stuff away for free. I don't do that. All right. So again, you're going to see this as we go on in here. That's all I can tell you. Then we have another method. What does this do? This returns the code, then a separator, which could be a comma, or it could be a blank space, or a tab, or a line break, or whatever. Then the price, then another separator, then the description. All right. I already told you that when you create an object from a class, it's called instantiation. So let's look at that. All right. So notice what we're doing here. Right here, that's declaring two projects, or products rather. It is not giving them values. That's what we do on the next two lines. All right. So this right here, okay, we're just declaring two products. Here, we're instantiating two products. So the first product, this is its code, this is its whatever we said was second, and that's its price. That's the description. Code, description, price, code, description, price. What they're using are some of their books. So they're making basically, where I used hardware stuff, they're making like a bookstore. All right? So if we don't want to do it like this, we can do it like this. These are called object initializers. Many people like to use these because it makes it clear that's the code, that's the description, that's the price, that's the code, etc. In fact, when I do mine, I typically put each one of these on its own line. So code would be on one line, description would be on one line, and price would be on one line. By no means do you have to do that. They could have put it all on one line as opposed to putting it on two lines each like they did. All right? So, as it says, when you instantiate an object, and instantiating an object, again, means when you create an object from a class, a constructor is automatically executed. If you don't create a constructor, one gets created for you that's like our empty one. Doesn't do anything, but it needs it. All right, so that's why it says there, if a class doesn't provide a constructor, a default one is executed that doesn't do anything. Typically, what the constructor will do is it'll initialize your values. So if we did that in here, that's initializing the code, the description, and the price, which is what we'd want. The data that makes up an object is also known as the object's state, just so you know. Once an object has been created, its state can change. What does that mean? Well, my guess is with all of us in this room that when we were born and the nurse took our height and weight, those have changed since then. You know, that kind of thing. So that stuff not only can change, some of it naturally will change. Some of it won't. You know, if you go through your, like with me, for example, and maybe that's fair, maybe it's unfair, but, you know, many women today, when they get married, keep their name. No problem with that. Some change their name. All right, so that's an example. I'm talking about last name. That's an example of a property that could change or could stay the same. But whatever you've got all your fields set to at one time, that's your state. And one thing about object-oriented programming, you want to make sure that your state it remains consistent all the time. It's not, how much do you weigh? I don't know. Then get weighed. Come in here with a scale. That kind of an idea. All right? I mentioned before when I talked to you about somebody building 60 houses out there. But when you think about it, even if you had 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, and you looked at these two houses, they would pretty much look the same, correct? But one could be sided and one could be painted. One could have a colored door, one could have a white door, all sorts of stuff. One could have, I don't know what else, but you get the idea. All right, but they'd still be things that were based off of the same class. All right. The state of an object changes whenever you change the properties or the public fields. An application can create 2 or more instances of the same class. That should make sense. Again, if I'm doing this for my hardware store, I better be selling at least 1 or 2 things. They could be thousands. It could be hundreds of thousands. The object initializers I showed you. Now, one thing, and you've seen this before, I just want to make sure that you know it. That is, if I do this, so if I come through here and I say int x equal 10, int y equal 15, int z equals add 2 x y. Now it's going to give me an error because I don't have an add 2. I'm going to quick make one. I'm going to say static int add 2 int, and let's just call them n1 int n2. Oops, not that. And I'm going to say return n1 plus n2. What is literally going to happen when we do this is z will be given 10 plus 15. Does that make sense? But you may or may not know this, but literally what happens is it doesn't pass x, it doesn't pass y. It passes this and this. Because when you're working with simple variables like this, it passes a copy of them. All right? Well, who cares? Why did I tell you that? I told you that because when you pass objects around, you don't pass in copies. You pass the address in memory of where the object starts. The reason that that's important is any changes you make in a routine to an object are permanent changes. All right, and that becomes really important, and you'll see that more later. All right, basic skills for creating a class. How to add a class file. Guess what? I just showed you. It's no big thing. If you didn't like it, so just so you know this, not here. But if you come in here, if I wanted to add another class, most people right mouse click, choose add, and class is at the bottom. All right, but you can choose new item and class from there. It does the same thing. There's absolutely no difference. All right, so why would you use, well, I use the other one because there's less steps. But if you don't agree, you can do it either way. There's even other ways that you can do that, but the way they show is the way I showed it. This is the starting code that you get. These are typically the system files that you'll need. The namespace, which is the same, you already know, that's the name you give to your project. And then it'll say class, and then whatever you call that product. I'm sorry, not whatever you call the class. All right, so they tell you how to do this, but it's what I just showed you. All right, how to code fields. Now, you'll notice there's differences here. First one says private int quantity. What does that mean? Quantity probably will have a default value of 0. All right, public decimal, that'll have a value of 0. But notice you can make things read-only. And if you make something read-only like that, it's like you made it a constant. You cannot change its value. All right. So we could have come in here. They're showing you another way to do this. This is different from the way I just showed you. In other words, notice public string, public, etc. See those? We used lowercase, and then we used down below where we had getters and setters. That's the recommended way of doing it. But you can do it this way also. Since the other way is the recommended way, I'm not going to talk anymore about this one. All right? Most of these definitions that are here, I've already given you. A variable that's not defined within a class is called a field. What does that mean? That means if I define a variable inside of a method, it's called a field. If I define it outside of a method, it's called a property. All right? A field can be a primitive data type, meaning simple, or a class can contain another class. What the heck does that mean? What if I created a class that I called time? And time had three things in it: hour, minute, and second. And then later I wanted to create another class that I called alarm clock. Couldn't an alarm clock have a time class inside of it? Not only could it, it probably would. All right, you'll see some of that as we go on. All right, again, most of the other stuff that's in here, we've already talked about. All right, how to code properties. We'll finish this sections up, and then we're going to take a break. I already showed you the get set. All right. Now, when you do this, if you put in a get and not a set, it's read-only. All right. If I put in a get and I don't put in a set, it's read-only. Reversing that, if I put in a set and not a get, it's write-only. Most of the time you don't use write-only properties, but you can if you want to or think you need to. Now notice in here, they've got, this is what we were already looking at, except we put it over multiple lines. But here, notice the difference. They've got to do a calculation first. All right? So, again, does that matter? It will as we go on. All right? So there's a statement that sets a property value. What does that mean? It means the value's on the left-hand side of an equal sign. Here's one that gets. So if it's on the right-hand side of an equal sign, it's a getter. If it's on the left-hand side of an equal sign, it's a setter. And as they mentioned out at the bottom of the page here, you use a property to get and set values associated with an object. All right? I will tell you, and I'm not just saying this, this isn't going to make a boatload of sense to you unless you read the chapter. And I know, yeah, he always says that. Well, maybe he does. But I will tell you, I'm just being honest with you, it won't make a lot of sense. Even if you do read it, it's not going to make a ton of sense, but it'll make a little more sense. All right? When you create a public method, this looks just like functions that we've been working with. Public, return type, name of the method, any parameters that you need. All right? And it's not ever mandatory that you need to take parameters. You know, you can always write a method that doesn't take any parameters. Not only that, you may have seen this before, you may not have. I don't know. But notice, if I come down here, right, this example I showed you before, I'm going to write in here, static double add 2, double n1, double n2, return n1 plus n2. All right? What you may or may not have noticed here, I'm not getting errors. And I've got two things, bless you, that are both called n2. How can I do that? Bless you. And it's because what's in here is different. So the system's smart enough that when I call this, it calls the add 2 that goes with this one. But if I were to come in here and say double A equals 12.3, double B equals 56.4, double C equals add 2 AB, I get no errors. But it's smart enough when it sees this one, it knows, oh, they're both ints. When it sees this one, it says, oh, they're both doubles. That's known as overloading something. I've got two routines with the same name. The difference is what's in the parentheses. So what's in the parameter list must be different. All right. And again, they explain that in here. You may or may not have liked my explanation, but it's pretty much they're saying the same thing in here. All right, again, not only can you overload a method, you can overload constructors. What does that mean? All right, again, going back to our example, let's jump over to our products class. I could do this. I could say public, product, and I could pass in, let's just say three things. Int A, double B, string C. Okay? And then based on that, that's spell public, right? I could do some stuff. Whatever the stuff happened to be. I don't care what it is. I could do some stuff. Then I could come down here and I could also have a public, in fact, I'd probably put it above, with nothing passed in. So public, product, paren, paren. All right, it's totally fine. There. And I could have another one. This is overloading the constructor. And you'll notice that the constructors look the same here and here. But what's in the parentheses is different. What I want you to get out of this is you can overload any method. And a constructor is just a special method that gets called when you create a new instance of something. That's all it is. All right, we're just about finished. We'll take a break in just a second. Finally, I think this is the one right before it. Yeah. So, static members. Now, you might think, well, I know what static is. We've been using it. Yeah, you have. But that's not even the point. All right? What I want you to get out of this, talking about static, is this. If I go back, I'm going to go back to our main. Okay? You know that if I add these two, I get 25. You know that if I add these two, it looks like I get what? 68.7. Okay? But what if I want to return this? All right? If I divide 56.4 by 12.3, I'm going to do it. So I'm going to come in here and I'm going to divide 56.4 divided by 12.3. And I get a really ugly answer. I don't know if you agree with that or not. All right? So I don't want that. I actually want let's just say I want 1 decimal place. All right? Which should be, if I did my math right, 4.6. All right? Then I can come in here and I can do this. I can, not that one, sorry. Here, I can say math.round. All right? And what does that do? It does the division, then it says round it to 2 decimal places, or 1, which is what I said before. The point is, I'm using something from a math class, and it's called round. It's the round method of the math class. And I'm asking you a question. Did I have to create a math object? No. That's what static really means. It means you can use something from a class without having to create an instance of the class. And that's what they end up saying in here. All right. A static member is one that can be accessed without creating an instance of the class. But to show the system it's static, you must use the static keyword. Now, we didn't use it there because I was just showing you an example. But in the ones that the object-oriented ones we'll use, you'll see it then. Static properties and methods can only refer to other static methods. Static has to play with static, for lack of better words. A constant that's declared with the word public is automatically static. In fact, if maybe you saw this already, maybe you didn't. If I come up here and I say const, I don't know, str equals a string. Doesn't matter. We're not doing anything with this anyway. But if I come through here and I try saying static, okay, I get an error. It doesn't understand static and a constant together. All right? So you never use that. All right, I don't know why I'm getting, it would be str, not string. Const string str, there we go. But if I come through here now and add static, it's not going to like it. Now, I was going to say, even if it doesn't show an error, it will not accept it when you try to run the program. And it says in here, the constant cannot be marked static. It's letting you know. So show potential fixes. It says, remove that. There's your fix. Well, it removed the whole thing, but again, we can come in here and say const string str equals a string. That's fine. If a class contains only static members, you can make the class static if you want to. All right? When we come back from the break, it's 9:05. We'll come back at 9:20. We're not going to go over much more, but we are going to go over pages 382, 83, 84, 85, 86, 87, 88. So about 8 pages. All right, so please come back at 9:20.